Hi guys. So today, before I start with the next concept, I'll just go with the one note, that is, while writing the set in a roster form, an element is not generally repeated, that is, all the elements are taken as a distinct, is nothing bad. I'll just take one example and I'll explain. The set of all letters forming the word school is nothing but we can write the roster form for this word is nothing but curly braces. I'll just write SCHOL. So what it means exactly is, while writing a roster form, if the elements are repeated, we'll consider only a once. Is it clear? So in the word school, in that O is repeated. So it is a twice is there, but we need to write O only a once. Okay, so this is what exactly the note. Hope you guys understood this. I'll just take one more example, that is, set of letters forming the word trigonometry. So in this word, I'll just write in the roster form is nothing but T R I G N O M E Y. In this, I'll not write this T and R again. Why? Because in this word T and R is repeated. While writing a roster form, you just careful with that whether the letter is nothing but any element is repeated or not. If it is repeated, you just write it only once, that letter. Okay, this is what exactly the note. So next concept is an empty set. So as we all know, empty is nothing but it is a null. Nothing will be there. So this definition is nothing but it is a set which does not contain any element is called as an empty set. And this empty set is denoted by the symbol phi or R, a curly braces with a blank. Okay, empty set is nothing but a set which does not contain any elements is called as an empty set, and it is denoted by the symbol phi as well as a curly braces with a blank space. Is it clear? So I'll just take an example that let set A is equal to x such that x is greater than 1 and less than 2. This x is natural number. So this is what type of representation is this? Is nothing but it is a set builder form. So each element of this set, it should satisfy this property where the element of this x, it should be in a natural number. So now we can write the roster for this as x, where exactly this is, which is greater than 1. Greater than 1 means it is a 2. But again at the same time, which is less than 2. So greater than 1 and less than 2 is nothing but you can take it that is 1.1, 1.2, etc. like that. But it is a natural number. In a natural number, there is no decimal elements, right? So there is no such element in a natural number, that is a number which is greater than 1 and less than 2. Hence we can write it this as a empty set or it is a null set. Okay, so next is a finite set and infinite set. So as we all know that a finite is nothing but if the elements are countable, then it is a finite, otherwise it is infinite. The same way for a set. A set which is a empty or consists of definite number of elements is a finite, otherwise it is a infinite. It's nothing but a set which is empty or consists of a definite number of elements is called finite set, otherwise infinite. Okay, even the empty set will also consider as a finite, or else in a set, if the elements are like a definite number, if it is a countable numbers, then we can call it that is a finite set, otherwise it is infinite set. For example, so I'll just take a set builder form only. Example, x such that x belongs to natural number and x square is equal to 4. So you can simplify this. X square minus 4 is equal to 0 is nothing but, I'll just write it, this is x square minus 2 square is equal to 0. Now it is of the form a square minus b square. So that can be written as a plus b into a minus b. A plus b into a minus b is equal to 0. Equate 0 for both the factors. X plus 2 is 0. X minus 2 is 0. It's nothing but x is equal to minus 2. X is equal to plus 2. So now this x belongs to natural number, but this x is equal to minus 2, it does not belongs to natural number. Therefore, the set which contains only a one element, that is only a positive 2. Okay, and hence it is finite. Is it clear? The second one, x such that x belongs to natural number and x is a prime. So this is set of all prime numbers, and since set of prime numbers is infinite, we can't count it, right? So if it is, there is a condition for a prime numbers in a natural number. If it is less than 20, then we can write how many prime numbers we will get within the 20. That we can write it. So, but here there is no condition for till how many prime numbers we need to write. In that case, we can't count it, and hence given set is infinite. Hope you guys understood this. So they'll give a set builder form like this. So with the help of that property or a condition, you need to write the elements in a set builder form, and you need to check with the condition whether those elements can be counted or not. If it is a countable, then you can say that it is a finite set, otherwise it is infinite set. Okay, next I'll just take it, that is the equal set. To define this equal set, we need at least two sets. Okay, I'll just take two sets, A and B. As we know that the sets are denoted by capital letters A and B. If every element of A is also an element of a B, and if every element of a B is also an element of A, then sets A and B are equal. Hope you understood this definition. It's nothing bad. I'll just consider two sets A and B. If every element of A, either it may be any elements, so every element of A is also an element of a B, and if every element of a B is also an element of A, then A and B are equal. For example, let's take A is 1, 2, 3 and a 4. B is 2, 1, 3, 4. Can you compare the elements of A and B? You're in a set A which has 1, 2, 3, 4, and in a B we have a 2, 1, 3, 4. Again, it is the same elements, right? The placement of the elements are different. It is not in order. So in a set A we have a 1, 2, 3, 4. It is in ascending order, whereas in a B it is not in a particular order, but all the elements of A which are also elements of a B, either every element of a B is also an element of A. Hence you can say that A is equal to B. There's nothing but A and B are equal sets. Okay. There is a note that a set does not change if one or more elements of the set are repeated, which is the note same as initially I explained. The note is nothing but I can take it the set A is 1, 2, 3 and a set B is nothing but 2, 1, 2, 3, 2, where A and B are equal. Why? Because in a set A we have 1, 2, 3. In a set B, here 2 is repeated thrice. So as I said that in a set, if any element is repeated, but we will consider only a once that element. Okay, is nothing but A is equal to 1, 2, 3. You can write it B as 1, 2, 3. In a set A and in a set B, all the elements are same, exactly the same. Hence you can say that A is equal to B. Hope you guys understood the sets, some types of sets, that is the empty sets, finite and infinite sets, and the equal sets. So that is what the next exercise in this chapter. So before that, I'll just take it one more example. Find the pair of equal sets if any. Give reason. We need to check this pair of a set is equal or not. It is a 0. B is a x such that x is greater than 15 and x is less than 5. So next, C is x minus 5 is 0, and D is x such that x square is equal to 25. Okay, now we need to check which pair of these sets are equal. So I'll just write it all the 4 sets in a roster form, so which is already there. B is nothing but greater than 15 and less than 5. It should be a less than 5, and also it should be a greater than 15. So not such elements, it is a empty. Next is C. X minus 5 is equal to 0. You can take minus 5 out of a equal. Is nothing but x is equal to 5. We have only one element. Next, D. So in this, x square is equal to 25. 5 square is equal to 25, also minus 5 square is also 25. There are two elements. It's nothing but I can take 5 and minus 5. Now we need to check which pair of sets are equal. So here A is not equal to B. Next, A is not equal to C. Of course, A is not equal to D. Then start with a B. B is it B is equal to C? No, B is not equal to C. Next, B is not equal to D. Next, if I start with a D, so obviously here it is there. D is not equal to A. D is not equal to B. D is not equal to C. So here there is no such a pair of sets are equal. Here all the pair of sets are unequal. So now a next exercise, which is a 1.2, which is based on the empty sets, then finite and infinite sets, and also equal and unequal sets. Is it clear? Hope you guys can solve those problems. I'll just take a pic of that exercise problems and I'll send you in a WhatsApp. You just try to solve them. Okay, hope you guys understood these concepts, that is the empty sets, finite and infinite set, and also equal sets. Okay, thank you guys.